Okay, let's do problem one. By differentiating or integrating certain power series, find a power series representing the function and determine the radius of convergence. Okay, so it's also from the geometric series. Okay, let's just do a quick review. Geometric series looks like this. It's the summation from 0 to infinity, a times r to the power of n. Okay, it is convergent if the absolute value of r is smaller than 1 and divergent otherwise. Okay, then if it's convergent, then the sum is equal to, right, then this sum, it is equal to a over 1 minus r. Okay, so if a function looks like this, a over 1 minus r, then it can be, transformed into a geometric series. Okay, so let's see. Part A, fx is ln 5 minus x. Okay, so now the problem is it's ln, right? It's not like a over 1 minus r at all. But remember, ln x derivative is 1 over x. Right? Ln x derivative is 1 over x. So this ln 5 minus x, it is an integration of 1 over 5 minus x. Okay, we are not finished here because if you integrate this, you use a chain rule, you still have an extra negative sign. So you also put an extra negative sign here. Okay, and now it looks much more similar to a over 1 minus r, right? It looks much more similar. So inside this integration, we can change it, right? So now this is a, right? I want this part to be 1. Here now I have 5, so I divide the top and the bottom by 5. Okay, I can do that. So now it looks exactly like this. So it's a over 1 minus r. Right? So it is, okay, the summation for n from 0 to infinity, a is 1 over 5 times r to the power of n. So r here, this part is x over 5. So times x over 5 to the power of n. Okay, and don't forget about this is equal to the infinite summation if the absolute value of r is smaller than 1. Right? This is the absolute value of r. If the absolute value of x over 5 is smaller than 1. Okay. All right. So now, all we need to do is to do this integration. Okay, this integration looks very complicated. Okay, the integration of the summation is equal to the summation of the integration. Okay, why? It's very easy. For example, if you integrate like x plus x squared plus maybe like 3x to the power 4, right? It's equal to integrate each of them separately and then sum them up, right? It's the same. So integrate summation is equal to summation, the sum of the integration. So it is, okay, and always a constant, you can move it out to simplify our calculation. So it's negative 1 over 5, these two parts put together, and then you swap the integral with the sum, right? From 0 to infinity, you integrate x over 5 to the power of n. Okay, don't forget about it's an integration of x. Okay, so it is an integration of x. So actually this 5 to the power of n, it's also a constant, right? You can move it out. So it is 1 over 5 to the power of n. You integrate x to the power of n. Okay, so now this integration is very easy. it is just x to the power of n plus 1 over n plus 1. Okay, and don't forget about the plus c. Okay, don't forget about the plus c. Okay, now let's simplify it. Okay, now let's simplify it. So first, everything that is related to n, we cannot move it outside this, right? But this plus c, that's the interesting part. Okay, you can see this is plus c times, right, the summation n from 0 to infinity 1 over 5 to the power of n. Okay? So anyways, this will be a constant, right? So this c means an arbitrary constant. So an arbitrary constant times a given constant is still an arbitrary constant, right? I randomly give you a constant, multiply a fixed constant, then it's still an arbitrary constant, right? So this c actually times 1 over 5 to the power of n and do the summation, the result is still an arbitrary constant. So that's why you can just move c out. Okay, minus, so because here I have 1 over 5, I have 1 over 5 to the power of n to, to make it more succinct, I can just write it as 1 over 5 to the power of n plus 1. Okay, and then this is x to the power of n plus 1 over n plus 1. Okay, so you can stop here, right? So in the answer sheet, it has a last step, re-indexing. You don't have to do that, okay? But if you want to do that, for example, just let t to be n plus 1. Okay, if you let t to be n plus 1, it's c is, okay, originally it's from 0 to infinity, right? Now t is n plus 1, so n is 0, n equals to 0 is equivalent to t is equal to 1, right? T from 1 to infinity, 1 over 5 to the power of t times x to the power of t over t. Okay? So this is it. Right? Then the last step is to find the value of c. Okay? Is to find the value of c. So don't forget, we have all these equations here, right? So this final answer is equal to this function. So we can just do a substitution, right? We can just do a substitution. We can just let x to be 0. If x is 0, then here it's ln 5. And if here is 0, it's just c minus 0. Right? So when x is 0, right, f0 is just ln 5 minus 0. It's just ln 5. And this complicated expression, right, is equal to, you can see when x is 0, this is 0, right? So this whole summation is 0, and it's equal to c, right? So that's why c is 0. Okay, so by that substitution, you can get the value of c. Okay, you can get the value of c. And in the end, we can leave it as t, or you leave it as n. It doesn't matter, it's just a name. Okay, this is the answer. Okay, what about the radius of convergence? It's from here. You can see from this step to this step, from this step to this step, the assumption is, right, this r. Remember here it's a over 1 minus r. This r, the absolute value of r must be smaller than 1, which means the absolute value of x is smaller than 5. Right? You can rewrite it as the absolute value of x minus 0 is smaller than 5. So this is the radius of convergence. Right? This is the center. Okay, so the radius of convergence is 5. Okay, so you can see now it's getting more and more complicated because you have to put everything you've learned together, right? Series, sequence, integration, right? You have to put them all together. So let's do part B. Okay, part B. It is x over 1 plus x squared. Okay, again, let's write down the geometric series. It's from 0 to infinity, a times r to the power of n is equal to a over 1 minus r if the absolute value of r is smaller than 1. Okay, again, here, it doesn't look like a over 1 minus r at all. All right, so just now we used integration, so now maybe we can try differentiation. Right, so what if you just differentiate 1 over 1 plus x? Okay, what do you get? If you differentiate that, you get negative 1 over 1 plus x squared. Okay, so you can see these two are a little bit more similar, right? But still I have an x on the top, right? But remember, your a could be any value, right? Your a could be any value. But here, a looks like it's this. So, right, so when you see the difference between here and here is this x, you can just split the x, okay, from this 1 over 1 plus x squared. Okay, and if you do that, you can see this is the derivative of, okay, it's x times the derivative of, okay, negative 1 over 1 plus x. Okay, let me put negative 1 on the top. Right, if you differentiate this part, you will get this part. Okay, I have an extra negative sign because here I have a negative sign. Right, and here you can change this to a geometric series. Okay, you can change this to a geometric series. Now, this is a, okay, let me rewrite this, a plus x. All right, so let's just do one extra step, rewrite it as 1 minus negative x. Okay, so now this is my r, this is my a, and it is equal to the geometric series. Okay, summation, and from 0 to infinity, a times r to the power of n. Okay, if the absolute value of r is smaller than 1. The absolute value of r is smaller than 1. Okay? And now, let's first write down the radius of convergence, right? Here it's very simple, so it's just the absolute value of x minus 0 is smaller than 1. So this is the center, a is 0, and the radius is 1. Okay? And all we need to do is to simplify this. Okay, again, so if you differentiate the sum, right, if you differentiate the sum is equal to the sum of the derivatives, right? Why? It's very simple. For example, if you differentiate like x plus maybe like sine x plus ln x, right? It is equal to, you differentiate them individually and then add them up. These two are the same, right? They have the same effect. Okay, it's pretty simple. So differentiate of the sum is equal to sum of the derivative. So, right, but before that, let's just reorganize what's inside this summation symbol. Okay, I have negative 1. Here, negative x to the power of n, I can split it into two different parts. The first part is negative 1 to the power of n. The second part is x to the power of n. All right, then we can swap the derivative and the summation. And from 0 to infinity, d over dx. So I have here negative 1 to the power of n plus 1, all right, times x to the power of n. All right, then here, okay, for x, this is a constant, right? Because you want to differentiate it by x, then this anything about n, it is a constant. Then you just differentiate, right? You just differentiate x to the power of n. The derivative is n times x to the power of n minus 1. All right, and then you see you have an extra x in front. So where is this x from? This is from initially you split this x away from this 1 over 1 plus x squared. Okay, but now it's a summation of n. So x for n, x is just a constant, so you can move it freely inside, into, or out of this summation. Okay, so you can move x in. You will have from 0 to infinity, -1 to the power of n plus 1 times n times x to the power of n. Okay, these two, multiply them together. All right, you get this. Okay, and as you can see, the first term, right? What is the first term? The first term n is 0, so the first term is actually 0. Sorry, the first term is actually 0, right? So that's why it's equal to, so you start from 0 or start from 1, they should give you the same thing. That's because when n is 0, it is 0. Okay, so you can also write it this way, which is the answer. Okay, which is the answer. So this is a final answer. Okay, this is a series representation of this function, and the radius of convergence is 1. Okay. So again, this question is difficult, I would say, because you have to be able to use all the things you have learned: series, integration, differentiation, right? Radius of convergence. Okay, also a lot of seemingly complicated algebra. Okay, so don't worry if you can't get it the first time. Just go back to all the atomic elements, right? If you are not familiar with differentiation, go back to differentiation. If you're not familiar with like geometric series, go back to geometric series and take a quick review. Okay, and think of it a few times. You should be able to get it.